is Dan Low, and I'm going to show you 4 ways to compute the mean, variance, and correlation in Spark Scala. So let's first take a look at basic statistics. So a lot of time we want to compute the average or mean of a set of values, like x bar is 1 over n times summation all the numbers together. And second thing, we want to compute the variance, for example, sigma squared, and that is defined by 1 over n times summation xi minus x bar squared. So x bar is the mean previous computed. Okay, and a lot of time doing the data analytics, we also want to find out the correlation coefficients of uh, two features in the data set, for example. So the first one is Pearson's correlation coefficient R, defined by the summation xi minus x bar times yi minus y bar. Okay, then divided by the square root of variance x and variance y. Okay, and another type of correlation is called Spearman uh, rank correlation, defined by rho equal to 6 times the summation of di squared divided by n times n squared minus 1. And where di is the difference between ranks of two variables. So the 4 ways I'm going to show you is based on Spark 3.0.2. If you use any other version of Spark, you might find there's some discrepancies. Just keep it in mind that if you use different version of Spark, you may not get the whole thing to work for some reason, so you need to tweak around. Okay. So the first one I'm going to show you is a for loop. Very straightforward. Just use the basic programming technique for loop. Okay, to go over each element in the data set and then do some manipulation. And the second one I'm going to show you is the map reduce. Okay, so Scala is designed to process big data. So you at least have to you know take advantage of Scala's map reduce functionality. Scala, by the way, is a functional programming language. So take advantage of map reduce probably is a step, it's an upgrade in your programming skill as well compared to just the basic programming. Okay, you can get things done using the basic programming technique using a for loop, but if we can take advantage of map reduce, that will you know increase your productivity a lot. Okay, the third one I'm going to show is RDD. So RDD is spatial data structure defined in Spark in a cluster of nodes, meaning the Hadoop file system. So we can take advantage of the RDD, and then I will give you some statistics automatically. And last one I'm going to show you is using the correlation object provided by Spark machine learning library. Okay, so let's start with the first one, for loop. So uh, this is a Spark shell. Okay, so to begin with, I'm going to define the data object. So I define the data object, say val data. Okay, so the data object, I'm going to define it using a sequence data structure. Okay, so the first one, uh, the sequence I'm going to just use a vector uh, dense. Okay, define a vector. Okay, inside the sequence, and the first one is, let's just say 3.0 for the x value, and the y value is 6.0. And notice that I may not have the vectors that dense, so let's give it a try. Okay, So then that's the data. So yeah, as I suspected, the vectors is not in. So vectors is defined in the Apache library. So we need to import that. So let's say import start with org. Okay, Apache Spark dot ml dot linear algebra, and so let's just dot vectors. Okay, so import it. So once I got the vectors imported, then I should have the vectors, the dense. Okay, so I can use the up arrow key, to bring the history back. Okay, so here's the first one I have, and then the second line I have is this. Okay, so this is the first uh, vector in the sequence. Okay, so the second vector I'm going to have, again I use the dense vector format. You can use a sparse vector so that you don't need to type in all the zeros in the vector as well. So the second one I'm going to 1.0 and then 4.0 because it was something simple, so we can verify easily. And the third one, I'm gonna just have 2.0 and then 4.5. Okay, so now those are the three vectors defined in the sequence. Okay, and then I need to close this. Okay, so now I got the data defined. I can try it out, say data, um, the first one. Okay, so I bring up the 3.0, 6.0. Okay, and then data 2. Okay, you will give it a 2.0, 4.5. Okay, so these are the x values: 3.0, 1.0, 2.0, and these are y values: 6.0, 4.0, 4.5. Now the first one I'm going to compute is the x bar. So x bar. So we can use a for loop to bring those values. But if you try to do some experiment like a 0, so data sub 0 referring to the first vector. Okay, and then if you want to access the x component, you can put a x at 0, there. So the data sub 0 will refer to the first vector and the first element 3.0. So you give it 3.0. So the y's value you can put sub 1, you give you 6.0. Okay, so we can access it to the x components. And what are we going to do to compute the x bar? Is basically we just use a for loop. As I mentioned, we use a for loop. So to do the for loop, we can do some experiments, say for loop, and then let index goes from 0 to 2. Okay, and then we can just simply just print out something. Okay, print out data sub I sub 0. Okay, so that's gonna print the x component out. Okay, 3.0, 1.0, 2.0. Okay, so what we have to do is just add them together and then divide it by 3, and then we got a x bar. Okay, so we can just put a variable, say var x bar. Okay, x bar, and initialize its value to 0.0, so it became a double. Okay, so now we have for loop. Let's say for I goes from 0 to 2. Okay, and then here we're gonna just accumulate all the values, okay, together. So it's a x bar. Okay, x bar, and then add the number data sub I. Okay, sub 0. Okay, so you're gonna add all the x component together. Okay, and that's pretty much about it. So now x bar should have value of 6. Notice that we add 3, 1, and 2 together. That's a 6. Okay, now you can do the x bar. Okay, assign to x bar divided by 3, and now the average. So that's the actual S bar. So this S bar, is confusion, but it's just accumulate all the values here. Okay. So that would be the S bar 2.0. So we done this part. Okay. And how about you want to compute the variance? Okay. So the variance is simply like you want to do first, you get a for loop and then accumulate the difference between the each value and the average S bar and square it and sum them together. Okay. So again, we can have a variable. Say we can have a variable say x var variance. Okay, x variance. So s var. So put the x variance. Okay, equal to 0 0.0 to begin with. Okay. Then again, we have for loop, and this for loop again would go from 0 to 2. Okay, that's gonna walk over each element in the x. Okay, so now inside here I'm gonna have x bar because x bar is in charge of accumulate all the squared difference terms. Okay, so the difference, okay, data, we have well, we have to first find the difference between the number and its average at bar and then square it. Okay, so here because we need to square the difference, so I'm going to use the math that power, and then here the value is coming from 0. Okay, and minus, okay, minus x bar. X bar is the one we computed earlier. Okay, x bar. Okay, and then this is the difference, and then we're gonna square it. Okay, and then accumulate it into the x bar, x variance. Okay, don't confuse this var and then the variable. And after that, I'm done. So that's accumulated. Okay, so after that, I should have x var. It's also 2.0. Why? Let's take a look at, because I have 3 to 1, right? So 3 to 1, if you minus the average, okay, then you got 2 to 2. Wait, hold on once again. Uh, you got well, 3 to 1. Okay. 3 minus 2 is 1, and 2 minus 2 is 0. So you got a 1, 0, and negative 1. And then if you square it, okay, you square it, so it's gonna be 2. Okay. So that is summation of the square of difference between the number and the S bar. So to find the variance, we need to do one more step. We divide by n. Okay, so S var is equal to x var. Okay, divided by n. N is 3.0. Okay, it's 3 numbers. So now you got S var already there. Okay, so this allows you to compute the mean and the variance using uh, the using the for loop. Okay. Now, if you want to compute, you can do the same thing to compute the y bar and the y variance. Okay. Then how about compute the correlation between x and y? Okay. So correlation between the x and y. Okay. So you need to have a for loop. Inside the for loop, you need to compute the difference of this guy. Okay. And times together. Okay. So uh, let's first have a correlation. Okay, let's say well, we first had to find uh, the x the y bar. Okay, y variance. Okay, y variance. But I'm going to show you how to compute the convolution part. And let me just call it convolution because you have the summation xi minus s bar times yi minus y bar. Okay, so that part, we first have the y y bar. Okay, so y bar, so we can have a y bar equal to 0 0.0. to begin with, y bar. That means in the average of y. Okay. So again, we can use the for loop to do it. So the for loop is for I goes from 0 to 2. Okay. And this time I'm going to compute the y. Okay. So the summation will be accumulated y's value. So y bar is equal to data I, and here sub 1 is the y's value. Okay. So I add them together to be the y bar. Okay. Then I should have y bar some value like 14.5. But now this is just accumulate of all the values. I need to divide it by 3. So to get the actual y bar. So y bar is equal to y bar divided by 3.0. Okay, so that will be the actual y bar. Okay, so now that I got a x bar, y bar, and then I can compute the convolution part. So again I have a for loop, like I goes from 0 to 2 to walk over each element. Okay, and now I should have the correlation. Oh, I need to have a temp variable, say xy something correlation. Okay, so okay, so let's say I have var xy. Okay, uh, correlation, correlation, xy correlation. So start with 0 0.0, now 0 0.9. Okay, now after that, then I get into a for loop. I goes from 0 to 2. Okay, and then again I'm gonna accumulate everything in the SY correlation. So SY correlation gonna accumulate the two terms, xi minus x bar times yi minus y bar. Okay, so the first term is data x I, first term is 0, right? This is x minus x bar. Okay, so I need to have another parenthesis here. Okay, so let's get times together. Okay, times data. This time I'm gonna take the y's component. Okay, minus. Okay, uh, y bar. Okay, so that will be the xi minus x bar times yi minus y bar, and times. So they two times together. Okay, and then uh, then then accumulate then together in the SY correlation. So that once I done, I should have this term. So SY 2.0. Okay, good. So once I got this, I need to divide it by the standard, not standard, sort of standard deviation of x and y. Okay, so that the SY correlation now is equal to SOI correlation divided by the square root of the the variance. Okay, sort of. Okay, so square root of the summation xi minus x bar squared. Okay, so I can use the math. Okay, that power to do the square root. Okay, but since this is square, this is this this is the square root of that the variance, right? So I need to do the 0.5. So but the base will be the two terms, summation xi minus x bar squared. Okay, but since we have the x bar x variance, if I times 3, and that will be that term. Okay, so it's x var times 3.0, it go back to the summation term. Okay, and this time I times together y var, okay, times 3.0, okay. So that go back to the original summation xi minus s I bar, xi minus s bar, okay. And then after that I do the 0.5, that's half. That means I do the square root, okay. And then altogether that will be the correlation of x, y, okay. I don't have y var. Oh, by the way, I haven't computed y var yet. I have y bar. I don't have y var. Okay, so anyway, let me just compute y var. Y var. Okay, 0.0 to begin with. Okay, y var. And again, I have for loop. I goes from 0 to 2. Okay. Now I compute y var. Okay. Compute by x the data I sub 1 minus y bar. Okay, so this guy gonna do, well, I need to square it, right? So I need to do a math.pow this guy and then square it, okay, and sum them together in order to compute the y variance. Okay, so like this. So I got a y var. Okay, but this one I also have to divide it by 3.0. So y var is equal y var divided by 3.0. So that will get actual sigma square. Okay. So once I got this, then I can bring up the correlation I have earlier, this one, and I'll compute it. So now I got a correlation, 0.96, pretty high. Okay, so that's the first method called for loop. Okay, now I'm gonna start the second method. So the second method is based on map reduce. Okay, I think I can go back here, four ways. Okay, map reduce. Okay, so map reduce, basically, I can use the map function to map another function to work on each individual stuff. And reduce will reduce a set of numbers into one number. Okay, so I will start with the computer X bar is the map reduce. So here I have the data. Okay, I have data, and this data I have 3.0, and the X component has 3.0, 1.0, and 2.0. Okay, so what I'm going to do, I'm going to take the X component out of it. Okay, so I can set a value, say the X component. Okay, is equal to data that map. Okay, okay. So because this is a list, then I want to take the first number out. So I can just say underscore. Okay, so take the first component. Okay, so we can, before we do anything, we can try it out to see everything work. So we map. So basically, data that map underscore sub zero will take the first component out of each vector. Okay, so it will give you this a list of 3.0, 1.0, 2.0. Okay, now because I want to sum them together, right? So I can just followed by another reduce function. Here the reduce function I'm going to use is the fold left. So fold left, and fold left, you need to give an initial value, to accumulate, and then followed by you need to sum them together. Okay, so underscore represent the numbers, 3.0, 1.0, 2.0, one at a time. So that if I fold left, fold left, then using this is gonna sum all these numbers 3.0, 1.0, 2.0 sum together, which is 6 in this case. So that will give you 6. Okay. So after I got a 6, then all I have to do, to get the S bar is just divide it by 3. Okay. So I can just simply say var x bar is equal to the previous one, the data that map. Okay, and then take the first one out and then fold left. Okay, for left with initial value to accumulate is this guy, and then sum them together. Okay, so after that I got a value 6.0, right? So in order to find x bar, I just divide it by the size of that thing. Okay, so data that size, okay, which is a 3 in this case, and then that will give you the number 2. That's x bar. Okay, and you can do the same thing for the y bar. Okay, using the map reduce. So y bar equal to this one. All I have to do is map the first number away, the rest will the same. Okay, so y bar is this. Okay, so once I got the x bar, y bar, next I'm going to get the x variance, right? So to do the variance, as you can see, we got the data mess up 0. It gives you three numbers: 3.0, 1.0, 2.0. Okay, but in order to find a variance, we need to subtract each number, subtract the x bar average from each number. Okay, so we can do some experiment to begin with. So you can first start map. So this guy gonna map the first component out. Okay, and then you can take you can actually take away the x bar from each component during the map. So here I got this number and I take away x bar. Okay, and then it should give you 3.0 minus 2.0, 1.0, 1.0 minus 2.0, negative 1.0, and so forth. Okay, so after that I got the x take away s bar for each component, and the next I'm just gonna square it. Okay, just square it. So I can simply just do this and then square it. We can just do square function map that pow. Okay, pow. Okay, and this guy then 2.0. Okay, so that it will square this difference 1.0, 1.00. Okay, so that will give you uh okay it's a error that we cannot use this guy in here. Okay, so we probably need to do two steps. So the first step is doing that thing. Okay, so the first step is just doing this thing. Okay, so it's doing get this out. Okay, so we know this one works, right? So just take out that one. Okay, and after that we just map again. So the map again. Oh, that pow. Then this guy. Okay, 2.0. Okay, so this guy, and then yeah, that's it. So now we got squared it, 1.0 squared 1, negative 1 squared 1. Okay, and that. And finally we need to fold them together. So fold them together is that we just fold same deal. We just fold left. Okay, fold left. Okay, then the first one is 0.0, and then second component is sum them together. Okay, so now sum all these squared terms together. Okay, so that became 2.0. But in order to compute the variance, we also have to divide by 3.0. Okay, so we can just simply say this guy and then divide it by the size of it. Okay, and then that will be the in this case is x variance. Okay, so we can just simply just change it, set it to x var. Okay, so x variance equal to this guy. Okay, and we can do the same computation for y variance. All we have to do is just take the first one out, and then the rest will be the same. Okay, and then hit enter. So we got the y var, okay, and y variance and x variance. Oh wait, hold on, I think got something. This is should be y, not x. Sorry. So this is should be y. Okay, and then yeah, okay, and then y is 0.72 y variance. Okay, and we can also map the two, okay, together. So to compute the correlation, this is a little bit harder in the map reduce because now you have two different data object x and y. Okay, but you need to compute the corresponding elements time together. Okay, so let's start with the uh, some well, we need some concept called zip. Okay, so notice that we have the data. We can get data. Okay, sub. We can that map. Okay, so we can take the first one out. Okay, take first one out, right? And then we can minus x bar. Okay, and then we can get a list of this. Okay, same thing. We can get the y difference. Okay, so we can get y and get x. But in order to compute the correlation, we need to time the first number 1.0 with this y is the first number 1.16. Okay, and the second number -1 times negative 0.83 something. So we need to do this kind of it's go over each go over each corresponding pairs. Okay, so we're gonna zip this guy and this guy together. Okay, and then let them compute the corresponding together. Okay, so here we can try using data in order to zip the both this had to be the same size. Okay, so let's assign this guy to let's say x. Let's say this is the uh, x div. Okay, as a div. Okay, and then we get y this guy. Okay, y div. So oh man, I think I got something wrong. That should be x. This should be y div, and that should be x div. Okay, anyway, so I need to recompute. So y div, x div. X div should be we get sub 0, and then this is x bar. Okay, that's x div. So we got an x div and y div. Now we're gonna zip them together. So I say x div dot zip. Okay, and then zip to y div. Okay, if I zip them together, now I can use map. Okay, uh, here the map function. Again, we want to we want to just time these two together, right? So here I'm gonna use some technique called case class. Okay, so here I'm gonna split this thing. Okay, this is after I zip together, I split it and use the A to represent the X component, B to represent the Y component. Okay, so then after that, I'm going to do A times B. Okay, together. Then and that'll be it. Okay, so we should get something like the first one 1.16 times 1.0 is 1.16, and the second one is negative 0.83 times -1 is 0.83. Okay, and the third one is zero point 0.3 times zero point 0.3 something. So it's something I cannot see some value there. Uh, wait, hold on one second. Uh, the negative zero point 0.3 something times 0 is 0. Sorry. Okay, 0. I put a negative 0, but anyway, it's 0. Okay. So now we got this computed. Okay. So after we compute that thing, the whole thing, okay, we just have to fold them together, add them together, because in order to compute the correlation, right? So so after that, I can simply just fold them together again for left. Okay. So starting with 0, 0.0 and then add them together. Okay. So I should get one number, 2.0. Okay. This is 8 point. 1.16 times point, yeah, it's about 8, about 2.0. Okay. So after adding together, then I just simply divide it by the square root of the x variance and y variance. Okay. So I can simply say divided by math dot power, okay, square root of the x variance, okay, x variance times 3, right, and then times y variance times 3, okay, and then put a 0.5 there because I need to square root it, okay. So that'll be it. That'll be the correlation. So that give you an idea about how to use the MapReduce to compute these, basic statistics. All right. Now let's find out the so is RDD. Okay. So the RDD basically what we need to create an RDD. So here I have let's say I have do I have X? I don't have X. So let's say I have X. X is coming from the data. So I get the X out. Okay. So X is 3.0, 1.0, 2.0, right? So in order to use the RDD method, I need to create RDD from this X. Okay. So I have val X RDD. Okay. So equal to I'm gonna map this to RDD. Okay. X. So this X is gonna I'm gonna create RDD for the the data set X. Okay. So now after I created the RDD, XRDD, you can take a look at the, let's say first, you get a 3, because I have 3, 1, 2, right? So XRDD, I got a 3, 1, 2, okay? So this is the RDD. And then if I say XRDD, the states, okay? And then you give me the statistics of this, okay? So here the count is number of elements, it's 3 elements. The mean value is 3 plus 1 plus 2 divided by 2 is 2. Okay, standard deviation is the variance, square root of variance, 0.81, maximum is 3. So that gives you the basics. And you can do the same thing for y, you know, so I can create a y RDD. Let's create a y first. Data, again, data, so here I created y, okay, using this. So y will have the y values, okay, out of the data set, okay. Then I have y RDD, again I use SC the pairwise that will create an RDD for y, okay, y. And then after that I have a y RDD that states, okay. So that will give you the statistics for the count 3 values, and then the mean value mean of the y is 4.83, standard deviation 0.8498, something like that. Okay, and then the maximum is 6, minimum is 4. Okay, so that's the method using RDD. And lastly, I'm gonna use the correlation objects in the in Spark. So the correlation object basically I need to, okay, let me go back here. So I have data, I created earlier, right? So so this data set, in order to use the uh, correlation object, I need to import the library. Okay, so I import. Uh, so I need to import linear algebra matrix. Okay, I need to import matrix, and then I also need to import the correlation under the state correlation. And then I also need the row, okay, because the data structure used in the correlation is row, so that I need to install. I need to import row. Row. Okay, so this is just to import the necessary library inside. So now I got the data I defined earlier. Okay, so the first thing is I need to convert this the sequence data set into uh, data frame. Okay, so in order to convert this sequence to a data frame, I need to, let's say, data frame equal to data. Okay, uh, I need to map each of the vector into a table. Only the table can be converted to a data frame. Okay, so map each of the vector inside the sequence to table. So to do that, I can use a function called table one that apply. So that way, after this map will apply this table one function to each of the vectors. So basically, you want to convert each vector into a table. Okay, that's what it is. So after that, you have to df use the after that you can have a 2df to convert it to the data frame. Okay, so here the data frame, since I have only one feature, I just want to get a feature, just features. Okay, then so that will give you the data frame. Okay, so data frame. Okay, and then df dash show. Okay, so you got a data frame. This these xy values. X values 3.0, 1.0, 2.0, and 6.0, 4.0, 4. Y's values is 6.0, 4.0, and 4.5. Okay. So after that, then you could just using some correlation objects method. So because correlation object will return row data type. Inside a row, it's a matrix. So I say here I have coefficient. Okay. Uh, here I think we call the correlation coefficient. We call R. Okay. R. Okay. So this R matrix is a matrix. Okay. Correlation is a matrix. So it's equal to the correlation that correlation, and then here I want the correlation to work on the df, which I converted, and then here the parameter features simply the tail. I want to compute the Pearson correlation coefficient R, and then because after this conversion I only need the head, which is the matrix with the correlation matrix. Okay, so you got a correlation matrix, and now you have x, well, x to itself is 1.0, y to itself is 1.0, but the correlation is 0.96. Okay, and this should be symmetric because of the correlation. And if you want to compute the Spearman rank correlation, so all you have to do is you just compute this Just a row, okay, matrix, coefficient, just do the same, but I need to add another Spearman to it, so that you will do the same computation, but not do the same computation, do the Spearman correlation, ring correlation, by the way. Okay, so in this case, it's everything's one. Okay, one. The reason is the ring are the same. The ring of x data and y data are the same. Because they are the same, so when you do the computation, it cancel out, so you get one. That means it's highly correlated in terms of Spearman's correlation, ring correlation definition. So that concludes the video. So I hope you enjoy and like it. And yeah, there are four ways, right? So if you are happen to be my student, at least you can do the second one, okay, using the map reduce, okay, and RDD provides some convenience for you to to find out the basis states of mean and variance, but for the correlation, RDD probably won't be able to help. But then the last one, correlation objects, this one will provide correlation, specifically. So I hope you enjoyed the video. Then I'll see you next time. Have a good day. Bye bye.